Hi, everyone. I hope you can hear us loud and clear. Welcome to the session. I hope you're enjoying One Summit so far. To introduce myself, I'm Tariq. I'm a principal architect at Telus. I'm leading the service orchestration effort from Telco Cloud team for the last more than 7 years. I have been working with this project Nephio since inception. I have been working as TSC Vice Chair and then working as the SIG Architecture Chair, as most of you know. And I really enjoy working with the project. I'm going to pass on to the next great presenters to present.
Thank you, Sana. My name is Bala. I'm with Red Hat. Along with me presenting, he's not in the stage, he'll come in later, Alexis. He's also with Red Hat. As a Red Hat, we are very much vested in the success of Nephio. Alexis is the vice chair of SIG Architecture. I'm the chair of SIG Release, and I'm also the member of TSC. So with that, I'll pass on to Sana for presentation.
Thanks, Bala. Let's start with something very fundamental so that we keep remembering the Nephio. What was Nephio? What are the principles? And then go dive deeper into some of our core concepts. So Nephio is a project that is uniquely positioned right now, supported by network function vendors, cloud providers, telcos, and now in the midst of all the evolution happening towards GitOps and GenAI, Nephio is uniquely positioned to deliver a cloud-native vision. Let's see why Nephio. So we had a zoo of automation systems. I have been working in this space for the last 10 years, and I know that we have lots of ways of doing things that we do with Nephio. For example, if you want to deploy a network function, you can deploy a network function to the cloud today. You can do the infrastructure automation through infrastructure as code. And you can also configure a network function with element management systems. So why really Nephio? I think the answer lies when you try to attempt to do all of that at scale. That's when the beauty of Nephio principle comes at play. So Nephio is actually based on 3 core principles, and it's very important for us to understand that at this stage, and then we'll refer to those principles over and over again throughout this talk. So the first principle, intent-driven. What does this really mean? So for example, if you want to do X, you would just say that I need to do X and allow the system to come up with the prescriptive details on how to accomplish that X. The second very powerful system that Nephio believes in is the actuation of your intent through constant reconciliation, which is the DNA of GitOps and the Kubernetes on how your infinite closed loop is all the time bringing your actual state to the ideal state, and it's running infinitely. It's a very powerful concept. And the last one is the uniformity of tools and systems. So in the current model, I have been working in the telecom systems for a long time. We have network functions, and each network function almost behaves like a pet. Their own deployment models, their own configuration models, and then we have a large number of tools and systems. When you actually scale that to cross-functional teams, large number of network functions, and a large number of networks, it becomes extremely complex, and it becomes an extremely high overhead on your operational teams. Nephio is relying on a fundamental Kubernetes pattern, a fundamental open source project that has proven itself for both scale and time. A common denominator across all the cloud providers, across all the networks, across all the network function vendors, and a skill set that is extremely accessible in the industry. So the commonality of your tools is actually one of the winning factor and a very significant core principle of Nephio. Let's go through the journey of Nephio. Nephio is about 2 years. We are celebrating second birthday for Nephio. It's a toddler, so already made so much success. Nephio R1 was really implementing the seed of Nephio principles. We came up with operators and CRDs, and we did that on the free 5GC as an example. And we had some very basic UI at the stage of R1. Now moving towards R2, R2 was basically living those principles. We again had the operators and CRDs for those patterns, but we extended that concept to ORAN, and we showed that to accomplish the ORAN network function deployment. There was significant improvement in the website and documentation that you can go on the website and see. And with the community's help, we were able to get the Nephio experimental section, Nephio SDKs, and we had the operator to Helm conversions, and we had Flux Helm-based deployments and a preliminary preview of the topology controller. Moving towards R3 and beyond, I think the theme for R3 is more looking like making Nephio real, because we are paying attention to some fundamental aspects, for example, multi-cloud and security, to make it real. And I work with Alexis in SIG architecture, and we are also working with the community to look at the longer-term roadmap for Nephio. And in the longer term, we have to really focus on the synergy of Project Silva and ORAN, and we have to continue the support of network functions, lifecycle management, which is one of the biggest promise of Nephio. And we are also looking at many different ways on how do we enhance the user experience in the designer studio, and how do we bring GenAI. And I have a special section towards the end on GenAI, which is the exciting part of this talk. And there is a big ecosystem of the Helm at the moment in the industry. So the operator SDKs that will enable us to convert the Helm to operators is also a significant part for us to continue working on so we can improve the adoption. This is an evolving architecture for Nephio. If you look at the gray parts, this is a surrounding ecosystem, and this blue box in the middle represents Nephio. So the existing ecosystem of the ORAN SMO and how it's evolving in the ORAN Alliance and how the existing service orchestration systems are actually currently deployed, it's an important aspect for Nephio to continue supporting these not-bound APIs. And Nephio has to evolve in a way that can be flexible to all the existing GitOps and CI/CD tooling that exist in all the service providers' networks. And at the same time, Nephio has to continue supporting multi-cloud and allow all the flexibilities in the networking layer to ensure that it's flexible and adaptable. And from this point on, I'm going to give it to Bala to dive deeper into the architecture.
Thank you, Sana, for the great introduction. That was a very good level set. So as you can see here, there are 3 boxes. Hopefully it works. These 3 things here. So 3 main use cases of Nephio are infrastructure automation, workload automation in terms of orchestration, and also configuration management. That is kind of depicted in the first line. And the rest of the boxes represented here are the components that support these use cases. For example, all the inventory resources, Kubernetes cluster orchestration, and Nephio is GitOps driven, and also the repositories. So some of these things we'll get into slightly deeper in the next slides. This is a C4 representation of Nephio architecture. This is at a very high level view where Nephio here in this particular is represented as a black box. And the rest of the systems that you see here is the system that it depends on and the actors and the personas that interact with Nephio. So the entire system of Nephio is represented here, which will get into the deeper details in the next slide. But if you look about the actors, there are network designers. They are responsible for creating the network packages. And then the network engineers, they decide on how to deploy those packages, how to configure the network topology, how to automate them in an intent-driven way, which is enabled by Nephio. And the Nephio principles are, it's completely intent-driven, and it's all based on KRMs. So it's distributed actuation. So if the entire system of Nephio works on GitOps principles, where the user, the network engineer, expresses the intent of the topology in Git, and then that is kind of synced to the API server using various GitOps tools, and then ultimately it's realized by the Nephio system. So that is the distributed actuation where you have a management cluster which can, where you express your intent, but then the intent is percolated to the GitOps systems that is managed by, that is actually, that will trigger the individual workload clusters. And this entire system, if you think about either the 3 use cases of infrastructure automation or network function automation or network configuration, all these 3 use cases we want to solve in a very uniform way. We don't want to solve the problems in different ways. We want to solve in common principles using intent-driven configuration as data principles using Nephio. So that's one of the main principles of Nephio architecture. So if you go to the next slide, here it expresses the architecture in slightly detailed way. It's a logical component diagram. It's not a deployment architecture. So one of the main components of Nephio is the Porch. Porch is a package management system that runs on the management cluster, and it is responsible for multiplexing the packages. You can express your intent in an upstream GitOps repo, and then you can say, I want this network topology and then I want this configuration that needs to happen on these, like say, these are my regional clusters, these are my edge clusters, this is the exact topology I want. For example, you can say, this is my 5G core, these are the instances where I need to have my UPF, AMF, and this is the RAN I need to have in the far edge network. You can express everything as an intent at the very upstream repo, and then you can specify certain parameters of each of the sites that you're interested in, and the purge actually takes your intent, and then it will run a set of, sorry. Sorry, okay. So it will run a set of function pipelines in the management cluster. So it will basically hydrate your intent into KRM artifacts that can be realized into multiple edge clusters. So this is a multiplexing system that we have. That's one of the main core architectural components of Nephio that we depend on. And in addition to that, we have on the workload clusters is where the actual the operators for network functions they run, and the reconciliation engine is at this point of time what the intent of this particular box is. We depend on the GitOps tools. Today we support config sync, but that's not the only thing that we support as a GitOps tool. There is an intent to support other GitOps systems as well in the future, which we are actively working on. And then the Git repository manager is the various Git systems. Today we support GitHub and Gitia. There is an intention to support other Git systems as well. And then this is about Nephio and ORAN. So one of the major use cases for the upcoming R3 release and beyond is supporting ORAN architecture inside Nephio. So in ORAN, we want to support both the OCloud components and also the SMO components using Nephio enablers. So at the very high level, in SMO level, we want to support, there is FUCOM, which is responsible for infrastructure management, and also NFO, which is support for workload management. So from the R3 and beyond level, we will be doing certain FUCOM enablement using Nephio enablers. Some of this realization will happen on the OSC, but we are working together with OSC and OAI to realize these use cases. So we will be writing a few adapters. So the architecture is such that the Nephio, whether you implement OCloud using Nephio or SMO using Nephio, they are very loosely coupled, and the entire interactions between them will happen via standard APIs that are defined by ORAN, whether it could be O2 DMS or O2 AMS. So ultimate intention is that even if you have a Nephio OCloud, and if you want it to manage by some other SMO, we should be able to do that. Or you could be creating a SMO using Nephio, and then the OCloud could be something else. That SMO should be able to manage your cloud. So basically, all these interactions is going to happen using the standard interfaces. This is where we have defined some of the northbound and southbound adapters for both NFO and FOCOM here. On the OCloud side, we want to leverage the existing work that OSC has done in terms of, for example, the inventory management, et cetera. But some of the work that we are doing, one of the main use cases, like I said, in case of Nephio, is the infrastructure automation, that is cluster provisioning and lifecycle management. So on that one, we are realizing that in Nephio in R3 and beyond, making certain assumptions because the standards are not ready yet from ORAN. So these are the main work tracks that we are doing in Nephio for R3 and beyond at this point of time. Like I said, one is the SMO and RAN domain management track. This is where we are implementing the components defined by ORAN in partnership with both OSC and OAI. for both FOCOM and NFO functions inside Nephio. Basically, some of the work is happening directly in the OST community and OAA community, and then we are tracking some of the work in Nephio GitHub. So it's a very good collaborative exercise between different open source communities. The other part is the ORAN NF tracks. So like Sana said, we already support the orchestration of OAI workloads. Our OAI team worked with us very closely in R2 release. We want to, our next step is to make sure we are deploying all those things in a very Nephio-specific way, but eventually we want to do it in a ORAN prescribed fashion for all the ORAN network functions. And the OCloud enablement track is like implement IMS using Nephio enablers. Like I said, especially the point of interest at this point of time is the cluster lifecycle management and provisioning, which we will be working on in R3 release, and some of them may spill into beyond as well. So at this point of time, I'd like to say a little bit about more concrete roadmaps for R3. Sana has given us something more about the vision of Nephio, but this is more about concrete short-term things that we are doing. With respect to ORAN, on the OCloud side, like I said, our biggest use case at this point of time is to create and lifecycle manage the OCloud Kubernetes clusters. So in the ORAN specification group, there is work going on to define the intent-driven Kubernetes native, cloud native way of handling this particular management of cluster lifecycle management. The standard is not there yet, but in Nephio, we are taking certain assumptions in terms of intent-driven approach there, and then we are closely working with OSC and ORAN communities to realize that. And this is the main use case, and from the lifecycle perspective, deletion of the clusters and the registration of the OCloud, those are also in the discussions at this point of time. Obviously, the network function orchestration perspective from the DMS angle, that's the main use case, the NF orchestration using the SMO, which is realized using Nephio, and then the day two operation of reconfiguration of network functions. SMO and RAN domain management is where we want to deploy the near real-time RIC without SMO to begin with, and when the SMO part is ready, using Nephio components, we would like to do that using SMO as well. So those are some of the use cases, and like depicted here, we are not working in silo. We are working in conjunction with, in a very close collaboration with both ORAN SC and OAI and ORAN communities here, and they are very actively involved. In fact, some of the diagrams, the architecture that I showed, actually are created by the members of ORAN SC and OAI team members, and we really thank them for that. This slide is about, the previous slide was more about the use cases that we are targeting for the R3 release. And this one is about the other use cases that we want to target in R3+ to make the Nephio platform more real. The main thing is the platform and infrastructure piece where we want to evolve Porch. Like I said in the first slide, Porch is one of the main architectural components for Nephio. So we want to evolve in the sense that we want to make it more scalable, more performant, and also other use cases that we have identified over a period of 2 releases. We want to make those changes in Porch. And then make Nephio work on the bare metal clusters. We want to make sure that Nephio is not only working on, even in our CI/CD environments, we want to create this environment where we want to create a real use case, real life topology where we can have multiple different bare metal clusters. We could deploy the core and the RAN workload and stitch the connection between them and make an end-to-end call. And then support multiple Git and GitOps system. Here, what I mean by that is maybe support GitLab in addition to Gitia that we have. And the GitOps system it's at this point of time, it works with config sync, we know that, but we want to support others such as Argo as well. And in case of security, increased OpenSSF score to 8. That's one of our goals. And Rahul is here. He's going to talk about that. About other things that we are planning in security. both OpenSSF score and identity and workload access management. We have another track for user experience modeling, where we are creating an SDK which enables the users to onboard their existing assets, such as Helm charts, into the Nephio platform to begin with, and also create operators automatically using Helm chart, automatically using CRDs. So, and then creating information and data models for Nephio. And the last one is the service assurance and observability. We want to make the workloads. We are trying to make some of the open source workloads more observable for SA use cases. We also planning to do the platform itself more observable to give the visibility into what's happening inside the systems when the deployment happens. And using that, the next obvious step is to do the closed loop automation using AI and ML. We are planning certain POCs for this particular release. But by the way, that's not the only AI use case that we have. And we have very interesting use cases of AI using GenAI, for which I would, Sana is going to give us a good overview of what her vision is and what are the different use cases that we solve using GenAI and Nephio. That I'll hand over to Sana.
Thank you so much, Bala. With that, we are transitioning into the other buzzword, like we heard this morning, that is GenAI. So we learned about ORAN, thanks to Bala. And now going into this next section, what are we thinking about GenAI and Nephio? So I have been very excited about this GenAI in general. Since the launch of ChatGPT 3.5, I think all of us are heavily impressed and fascinated with what this can do for us. If I look at Nephio, I think there are two broad aspects of what GenAI means for us. The left-hand side, you can see, is basically how do we improve the user experience. For example, the job of a DevOps engineer or a network engineer who's working on automation, what wonders can we bring with GenAI to his life? Template generation, of course, large language models, which can understand natural language processing, can come up with any kind of code semantic. We can create templates, for example, CRDs, Tosca, KRM. And the template hydration is another huge investment of time. I'm working from cloud team. I believe cloud in itself is basically a combination of APIs, software, and lots of templates. And the operational teams working in cloud are about 80% of the time working on creation of these templates and management of these templates. So how do we make their job easier? I have personally done some demos on template generation and hydration, and the initial results that I've seen are very promising. I want to bring that to Nephio. The code generation aspects of developing SDKs and APIs, I think it's very exciting. We have to pay more attention to that and see what we can explore and how can we accelerate the journey. The right-hand side are the use cases that are going to improve the networking experience of the workloads deployed through Nephio. So what do we do? The cloud optimization has lots of opportunities on how can we improve cloud capacity, energy, and cost. For the 5G and RAN and edge, we have lots of use cases on how can we improve efficiencies and reliabilities through achieving closed loop. And there are lots of interesting projects out there, Anita and others, where we can do network operations with GenAI. So this slide tells you what we can do with GenAI for Nephio. I have the next two slides, which are going to walk you why and how, which is basically the most important part of what I want to bring to Nephio. With this, I want to help you understand why Nephio and the principles of GitOps are really a winning match for GenAI, and why this makes so much sense. So if you have been working in the telco industry, you know how we see the intent at the higher level of your stack. For example, I want to launch an EMBB network slice with an SLA that has the minimum download of 100 megabits per second, I'm making it up, and latency below 20 seconds. Now, there is a system below that, which is kind of translating that higher level intent to say, oh, for that intent, I have to deploy a 5G core with certain capacity, for example, 10 million concurrent sessions, and I have to integrate with ORAN. And for each of these intents, there is a closed loop, which is abstractly defined in, for example, 3GPP or in the HC world. Now, how do we break this intent down at the Nephio layer? For example, we reach the Nephio layer. And for Nephio, this intent realization means that, oh, I have to deploy a CNF, SMF, AMF, UPF, and then I have to configure ORAN, maybe using some of the user stories that Bala described. If you decompose the SLAs of all these upper layers at the very lower layer, where we have the resources and actual actuation, this boils down to this GitOps loop, observe, analyze, act. And how does Nephio implement that? We already learned about those principles, but I'm going to reiterate that. The actual state we define in a CRD, the ideal state. The operators act on that, and we have the telemetry to constantly sense the current state. Today, if you look at your existing GitOps pipelines, there are humans working on writing CRDs. There are humans writing operators, for example. And the observability tools, there is always a human working on some of the identification of a drift from the actual state to the desired state. We can use GenAI to write those CRDs. For example, the intent of the ideal state can come from a GenAI system. We can write operators with GenAI. We can even discover the current state from all those tools through GenAI. And the intent itself can be given by generative AI tools. So where did the humans go in this loop? I started worrying about this myself when I looked at that. No. Humans will be doing something bigger and better at that time. So for example, I'll be at the higher level of the stack. I would wake up in the morning and I would say, oh, I want to launch a new service, a new digital service, and by the night there are thousands of customers on it. So we are the crown of creation. We'll be doing something bigger and better, but the opportunities are endless, and that's the perfect technical landscape to implement that. And this is the last slide, where I want you to say how, and it's not too difficult to accomplish. So the things that I'm showing on the top is a traditional standard loop for the large language models. These are the large language models, which has a lot of potential, as you know. We saw a very cool demo by Kandan this morning, where he has trying to show some of the large language models and the capabilities. I want to do something like this for Nephio. Myself and Alexis, we were thinking of having another special working group, work group 6, where we would dedicate all the efforts to the GenAI. So let's focus on the lower level of the loop. That's called retrieval augmented generation. And the RAG pipeline is not extremely difficult to implement. So what does this do? For example, you can expose your Nephio data to a RAG pipeline. Your code repo can be exposed to Nephio back to the large language model. Your config files can be exposed, and all the data that you're collecting for the network troubleshooting and performance can be exposed. Now this user who's doing the prompt to the large language model can actually go through this retrieval model, and it can fetch the contextual data, attach that to the prompt, and can give it to the large language model. And in this case, through the RAG pipeline, the response is going to be way more accurate than before. I have personally done some demos on this. Within my own cloud team, I have come up with Terraform templates. I have come up with a template hydration. There is something I'm bringing to the Nephio Day by inviting another company who's going to show some of these large language models and how does this work. And this is something I'm very excited for, and I really want to do this for Nephio community along with Alexis and, of course, the rest of the group. It has not been done yet. And if you guys are feeling excited about that, I think I would love to have additional volunteers to come do this with us. And with that, we are opening the floor for questions.
Yeah, one thing I wanted to say is, thanks, Alexis, thanks for coming on. So we did not dig deeper into the architecture just because in the interest of time. But if you see some of the slide here, there is a link. We have provided the link for the Nephio doc. Oh, sorry. Where there's a link here where you can get into the more details. And there's a Nephio Day on Thursday. Please plan to join us.
Any questions? You have 2 minutes. Don't be shy. All right, well, thank you very much, everybody, and hope to see you Thursday.
Yeah. Thank you.